I don't ever slow up, no I don't take sh**. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take sh**. I got no love for the fakeness. If you want.
We've got this question from 2018 in March, and the question was asking us to calculate the current flowing through the 15 ohm resistor, which is this one, using superposition. Now, we've never done anything like this before, even in the examples in the textbook. There's no question like this before. If we had a question that was like this, that was asking us to calculate the current through the 15 ohm resistor using Kirchhoff's laws, that would have been easy, right? But then this question is asking us to calculate current flowing through the 15 ohm resistor using superposition. Now, what I would recommend we all do is we take a question like this and then we try to find out what are we familiar with, right? Now, the question that you are most likely familiar with is a question like this, where you've got a battery with a resistor in series with the battery, and then you've got the load resistor in parallel, then you've got your battery on the side with its resistor there. And then most of the question would want you to calculate the current flowing through the load resistor using superposition, right? But then this circuit is different. So what we're going to try and do is, we're going to try and answer these questions. We're going to try and answer this question by using superposition, and then we're going to try and make this circuit look like this circuit while we are solving for the current. Are we together? Now, what I recommend we do first is we try to write down the formulas, or we try to write down the formulas that we need to take in order for us to get to the answer. Now, the first step says that you need to calculate the total current, right? Let me write it down here. Oh, sorry. Let's start with the very first step. The very first step is we short circuit one of the batteries. So let's rather start by short circuiting V2, right? So short circuit V2. Now if V2 is short circuited, that means our circuit now looks like this, right? Still the same circuit, but just a slight difference in the resistors, and now we only have got one power source, right? Now this means that this V2 is not there if it's short circuited. So our formula, our circuit now looks like this. Now from this point onwards, now let's try to take this circuit to make it look like this. Are we together, right? Now if we're going to do superposition using this simple formula, the first step was going to short circuit V2, then our formula would have looked like, our circuit would have looked like this. So let's try to take this circuit and let's bring it so that it looks like this. Are we together? Good. I knew there was something missing. Yes. This is something that's missing. So our formula now says we need to calculate the total current that is flowing through the circuit. And the formula goes like this: E1 or V1, whichever one you prefer, V1 all over R1, which would be the resistor that is in series with your power source, and then plus the whole resistance of the circuit, right? So what I recommend we all do is, I recommend we solve for these three together, right? So that we can try and follow the formula as close as possible. Because the formula, they say RL times R2 over RL plus R2. This is what the formula recommends. So let's try to replicate this circuit so that it can look like this, so that we can apply that formula. So what we'd rather do is we'll take this R5 resistor, this R3 resistor, and this R4 resistor. And then let's merge these three resistors into one. Now after merging these three resistors into one, then our circuit will now eventually look like this. Are we together? So taking a look at R4, R3, and R5, right? You find out that R5 and R3 are in parallel, right? Parallel. And then this parallel part is in series with the R4 resistor. So let us calculate, let's just call it Rx, meaning the external circuit, right? So for our Rx is going to include R4, of which R4 is in series, plus the parallel part, right? Which is R3 by R5 over R3 plus R5, of which our R3 is given at 12 ohms plus that one is going to be 15 by 10.5 over 15 plus 10.5. If you itemize it on the calculator, what do you get?
What 18, 17?
18,
17.
Yeah. 17, 1, 7, 1, 8,17.
18,17.
Yeah, so
Only two decimals.
6.
6. Okay, ohms. Now, what this circuit now looks like after we've done this, let's just redraw this, right? Now, our circuit now looks like this, right?
And we have this question, something like this
In the final exam.
yeah.
Yeah.
Look like this.
So now our circuit now looks like this, right? Now, this is still our R1. This is still R2. And now this R4, R3, and R5 have now been replaced by Rx. Are we together? Now that means we can now take this formula that we have. We can now put the values into this formula. So our V1 was given at 20 ohms. And then our R1, we have it at 10 ohms. Plus our R2, which is given at 8 ohms. And then it's going to be 8 multiplied by Rx. Rx, which is 18.176, divided by 8.18,176. Thus becomes luminaires. What do you get?
So we got 1,285.
Now we've got 1,285 amps. This is the current that is flowing from this part, right? So now what we need to do now is we now need to be able to calculate the current that is flowing through this 8 ohm resistor. Now if we're going to use our superposition, we know that the next step is to now calculate the power, or we now need to calculate the voltage, right? That is at this other 3 resistor, right? So in order for us to get the voltage that is flowing at this other 3 resistor, we now need to subtract all the voltage drops that are coming here. Are we together, right? So we've got our R1, right? Which is, so it's going to be 20. Let me write down the formula and then we'll explain it as we go along. It says VAB, right? And VAB will be this part. This part will be A, and then that part will be B. So we're trying to find out the voltage flowing through at point A and B, right? So in order for us to get that, we now need to find out what are the voltage drops, right? Up until we get to VAB. So we're going to create loops, just like the loops that we have in Kirchhoff. And my loop is going to go like this. So if my loop goes like this, that means we're going to start from our total voltage, which is V1, right? And then from there on, we're going to subtract the voltage drop caused by this resistor, which is going to be plus, let's call that one V2. Sorry, this is a minus, because that one is the supply. And then we're also going to remove the voltage drop that is being caused by R4, right? So in order for us to itemize that, let's just put it at V4. Now, the formula for calculating voltage drop is current multiplied by resistance, right? That's Ohm's law, current multiplied by resistance. So in this case, we do not have the current that is flowing through this R4, right? But what we do have is we have the total resistance for this part. And we've got the total current that is flowing through. Now, there is another concept in N2 that you're supposed to know. There are some you know it once you get to N4, because it's the N2. That is known as the voltage divider rule. So the voltage divider rule, now let me just give a description, or let me just give an example of what a voltage divider rule says. And then in this case, we're going to use current instead of the voltage divider rule. So it says that So it says that if we've got something like this, right, 2 resistors in parallel, and then we've got a total current of, for an example, just an example, 20 amps flowing through, right? And then the value of these 2 resistors, let's call this resistor R1, let's call that resistor R2. And the value of these 2 resistors are known. We can accurately predict the current that is flowing through R2 and the current that is flowing through R1. Let's just make an example. Let's say this is 5 ohms, right? And let's say this is how many ohms? Let's just say 10 ohms, right? 10 ohms. So we can accurately predict the current that is flowing at R1 and the current flowing at R2. So the current flowing at R1, we calculate it by saying resistor, the R2 resistor divided by the R2 resistor plus the R1 resistor multiplied by the total current. This is how we get the current flowing through the R1 resistor. If we want the current flowing through the other two resistors, we will say R1 over R2 plus R1 multiplied by the total current, like this. Because current is inversely proportional. If current increases, the resistance decreases. And if the resistance increases, the current decreases. So that's why these two are vice versa, right? Let's just play around with this example. So that means 5 divided by 5 plus 10 multiplied by 20. What does that give you?
We got 6,667.
6,667, right?
Yeah.
That means that the current flowing through here is 6,667. And if you are going to do the same thing here, it will be 10 divided by 10 plus 5 times 20. And I'm sure your answer there is going to be 13.3333, right? 13.333. That means here you've got 13.333 amps. This is the current flowing through this resistor, right? So we're going to apply this same method to this part, right? So now what we now have calculated now, we already know the resistance for this parallel part together with that other 4 series resistor. And we know the resistance here at R2, right? We know the resistance of R2 and we know the resistance of this part. So in order for us to get the current that is flowing through here, is what we're going to do now is we're going to take this same part. Let me redraw it again, right? And then this is your Rx, right? And then this is your R2. So we can calculate the current flowing through R2 and the current flowing through Rx. Because we now know that the total current that is flowing is 1,285, right? So we're going to use the same item. So let's just call this current Ix, right? Ix, because we don't know it. So let's find out how we can know it. So in order for us to get to this resistance, what we need to factor in is this resistance. Are we together? So it's going to be R2 divided by R2 plus Rx multiplied by IT. Are we together? Or I1, which is going to give us R2 was given at 8 ohms. So it's going to be 8 divided by 8 plus 18.176 multiplied by the total current, which is 1,285. What do you get? What becomes to do? You get 0,408 amps. So now let's proceed with this formula here now, right? So it's now VAB is equals to V1, which is this one that we have here, which is 20 minus V2, which is this one that we have here, is going to be the current flowing through here is the total current, which is 1,285 multiplied by the resistance here, which is 10 amps, right? Minus the resistance here, or let's start with the current. The current there we've calculated it to be 0,408 multiplied by the resistance here, which is 12. What do you get your answer as?
2,254.
I was slightly wrong. You get 2,254 volts. Now 2,254 volts is the voltage here at R3. I went to get right. That's now our VAB. So in order for us to get the current that is flowing through here, we're not just going to say the current flowing through there is equals to voltage divided by resistance, right? That's Ohm's law. And then voltage flowing through there is equals to 2,254 divided by the resistance there, which is 15. What do you get your answers? 2,254 divided by 15. Thus becomes to 0,15026. So we can leave it at 0,15, right?
Okay.
This is amps. Now, this is the current that is flowing through the R3 ohm resistor that is being supplied by the 20 volt battery, right? So we're going to do the same thing on the other side, right? Let's do the same thing on the other side, right? So I'm going to try and keep this part there. And then let me wrap this side off here. And then we're going to make a plug from there. So we're going to do the second step. We're going to start with the first step again, which is short circuit V1, right? Short circuit V1, that's going to be the first step. Short circuiting V1. Now, by short circuiting V1, our circuit now is going to look like this, with R1 here, and then with R2 there, and then you've got R4 there, then you've got R3 there, then you've got, that's a lot of resistors, R5 here, together with its power source. This is the new circuit that we now have, right? Now, short circuit V1. V1 is no longer there. Now our circuit now looks like this, right? So the very first step that we need to do is we now need to put in our formula, right? Now this is going to be I2 is equals to V2 divided by. Now what you're going to do is that this resistor, since it is in series with the battery, is still going to be there, right? Which is R2. Oh, sorry, that's R5 for me, plus, and then after that, we're going to include this R3 ohm resistor, R3 multiplied by the rest of the circuit. The rest of the circuit is this one. Are we together, right? That's the rest of the circuit. So we're going to now calculate, let's call it RY, right? So still exactly the same thing that we did there. So let's call it RY. And RY is equals to R4 plus R2 multiplied by R1 divided by R2 plus R1. So our R4 is given at 12 plus, and then R2 we have it at 8 multiplied by 10 over 8 plus 10. What do we get our answer as, Minaris? I'm guessing 16 comma something is your answer there. 16, yeah. That's the answer. That was a guess. So you get 16,444 ohms, right? 16,444 ohms. Now let me redraw the circuit and then we'll see what the circuit now looks like, right? Since we have now calculated ROI, so our circuit now looks like this. Let's start from this battery, right? This is your R5, like this, and we've got R3 there, and now we've got RY. Are we together? This is what our new circuit now looks like, right? It's going to be R3 multiplied by our RY. It's going to be R3 plus RY. So from here onwards now, this is supposed to be R5. This is supposed to be R5. Sorry. This is supposed to be R5. R5 is in series. I don't know why my 5 looks like that. So let's start. V2 is given at 30 ohms, right? V2 is given at 30 ohms divided by the resistor that is in series with the power source, which is R5, is given at 10,5 plus, and then we've got this one, 15 multiplied by the rest of the circuit, which is RY, which we calculated and we got 16.444 divided by 15 plus 16.444. What do you get your answer as, Minaris?
So we got 1,635.
So our answer is 1,635 amps, right? Now, the next step is to now calculate the voltage at VAB. Now, on this other side now, since our R3 is here, right, there is no need for us to calculate whatever that is going on here at RY, right? So we're just going to take in our formula, which says VAB. This is now VAB2, right? VAB is equals to V2, which is this voltage that we have here, minus the voltage drop that we have here, right? Minus the voltage drop that we have here. Let's call it V2, right? So these are the only two voltage drops that we have. Sorry, these are the only two voltage drops that we have. If we are going to take our loop as this, right? It's still Thevenin, but all these formulas and theorems, they tie in together, right? So if we are going to do making AB subject to the formula, it will be AB is equals to V2 minus whatever name that you give to that one. We'll just call it let's call it V3 here. Let's just call it V3 so that it's simple, right? So our V2, we have it at 30 volts, right?
Yeah.
30 volts minus voltage is equals to current multiplied by resistance, right? So our current here, we calculated it to be 1,635. Multiplied by the resistance there, which is 10,5. And your answer, you get it as, my answer is 13, 13 is 2. It's not 13. My answer should be 12, something.
Whoa.
It's 12.
8,
Oh, man, I'm awesome. 12, 8325. So 33 volts. Now this is the voltage that we are flowing there. Now, since we've calculated the voltage flowing at AB, right? Now the next step is for us to calculate the current that is being produced here. So our current, let's call it I2, right? And with a dot on top. So our I2 is equal to voltage divided by the resistance. And the voltage, we calculated it to be 12,833 divided by the resistance here, which is 15. What do we get our answer as? I'm very positive, 0,80.
0,8555.
I was there. 0,8553. So you just 0,855.
Yeah.
So it's fine. 0,855 amps. Now that we've done, we now need to add the current that is produced by, we now need to figure out, right?
Starting from R1.
Yes, starting from this voltage V1 and V2. We now need to see if these two voltages are adding their currents onto R1, or they are fighting each other, or they are removing their currents from R1, right? So, okay, so I also had another question. Someone was asking me that if they are like this, we should subtract, right? So my answer to that is, don't look at this. What I would rather prefer you do is, I would rather prefer you decide, right, on your form of current flow, whether it's going to be conventional current flow or electron flow. And then you trace the currents from the batteries to see if they are going to add each other when they get to the load resistor, or they are going to subtract each other, right? Makes sense? So let's use electron flow, right? And then you say current that is being produced by V1, it goes like this through R3, right? Let's see. Same flow, electron flow, it goes like this, right? So that means that these two currents are adding each other, are we together?
Yeah.
But if the polarities were different, that would mean that if the battery was like this, right, that would then mean that this current is going to be subtracted to this current. But then these two batteries are working together, right? So we're going to add them together. So it's now going to be IT is equals to I2 with a dot plus I1 with a dot, which is equals to 0,855 plus the current that is being produced by that one, which is 0,15. What do you get your answer as? Now, this one I can give it to you. Wait, I'm getting 1,05.
1,005.
1,005. 1,005 amps. Now, this is how we do this question that we got that looked difficult in the beginning, but then these questions are all easy. Difficult. Now, these questions are all easy. I need all of you to disrespect this topic.